Welcome to Next Gen Manufacturing. Today, we're going to break down one of the most crucial moments in any machining operation, that very first cut. You know, how a tool enters a workpiece can literally make or break the entire job. So we're going to show you how to master the art of that first touch.
So let's just jump right in with a big question. What is the single most punishing moment for any cutting tool? Well, the answer is that initial engagement, that very first contact with the material. If you get it wrong, you're not just looking at broken tools. You're talking about scrapped parts, expensive machine downtime, and deadlines that just go right out the window.
So here's how we're going to tackle this. First, we'll talk about why that first cut is so darn critical. Then we'll explore different strategies, from the, let's call it the direct approach, to more advanced paths of motion. We'll look at the gold standard for precision, help you make the right choice for your job, and then we'll finish up with some tips for mastering your entry, every single time.
All right, let's get into the fundamentals here. That first cut, listen, it sets the stage for absolutely everything that follows. It's a moment of incredible stress on the tool, and figuring out how to manage that stress is the key to successful, efficient machining. It's as simple as that.
So what do we really mean by tool entry? Well, it's that first moment of contact. You can think of it as the moment of truth. And it's pivotal because the forces that get generated right here in this instant can dictate your tool's life, your surface finish, and really the overall integrity of your part.
And this quote just hits the nail on the head. Calling it one of the most punishing operations is not an exaggeration. A bad entry can cause a catastrophic tool failure in a split second. Or it could be more subtle, causing this slow, cumulative damage that just wears your tool down way too fast, costing you money and causing all sorts of headaches down the line. Okay, so let's move on to our first set of techniques, what we're calling the direct approach. Now, these are really common, very straightforward methods, but trust me, they come with some serious risks if you don't know the rules of engagement. So here we have the two main direct methods. On the left, you've got the straight plunge. This is exactly what it sounds like, and it is incredibly risky for a standard end mill. Why? Because the flutes don't meet in the middle, leaving this dead zone that literally can't cut. That's a job for a drill bit or a special center cutting tool. Now on the right, you've got a straight entry from the side. This is also really tough on the cutter. So the big takeaway here, if you have to use this method, you need to reduce your entry feed rate by at least 50%. Give that tool a fighting chance.
All right, so that's the brute force approach. Now let's get a little smarter. This brings us to more advanced strategies that use what we call intelligent tool paths. So instead of a direct assault, these methods use controlled motion to sort of ease the tool into the cut, which helps manage those forces and gives you a much better outcome.
First up is ramping in. I want you to imagine walking down a ramp instead of just jumping off a ledge. That's the whole idea here. The tool enters at a nice, gradual angle. Now, this method does put a lot of twisting stress, that's torsional force, on the tool, and that's exactly why it's so important to use a tool with a really strong core. Also, adding a corner radius to your tool, that's going to add a ton of strength right where you need it most. And the angle you choose isn't random. This table gives you some fantastic starting points. See, for harder ferrous materials, you want a really shallow angle. We're talking just 1 to 3 degrees. For softer, non-ferrous stuff like aluminum, you can get a lot more aggressive, maybe ramping in at 3 to 10 degrees. It's all about matching your approach to the material's resistance.
Next up, we have controlled side entry methods like arcing and rolling in. Here, instead of a straight line, the tool follows this gentle curve into the material. This gradually increases the cutting load, it avoids that initial shock, and it lets the tool naturally build up to a proper chip thickness. And yeah, just like with a straight side entry, for a roll-in, you're definitely going to want to cut that feed rate by 50% to make sure you get a nice, smooth transition. Now, let's talk about the gold standard. These are the safest, most precise methods out there. They're especially critical for next-gen manufacturing, you know, in fields like aerospace and medical, where failure is just not an option.
The safest method, bar none, is the pre-drilled hole. You're basically clearing a path for the end mill, so it doesn't have to do any of that punishing plunge work at all. This massively reduces wear, helps chips just fly out of the way, and it's hands down the best way to protect your tool. Just remember the crucial detail. That hole needs to be about 5 to 10% larger than your tool diameter.
Next is helical interpolation. I want you to picture a corkscrew smoothly entering a cork. That's what's happening here. The tool follows a spiral path, or a helix, down into the material. It's incredibly safe, and it's the go-to choice when you need those pristine surface finishes and tight tolerances demanded by high-spec jobs.
And here is a critical number you'll want to remember to make this method work. Your programmed helix diameter should be greater than 110 to 120% of your cutter's diameter. This gives the tool just enough room to work efficiently, and really importantly, get those chips out as it spirals down.
Okay, so we've laid out all these different methods, but how in the world do you choose the right one? Well, this next section is all about putting this all together into a really practical decision-making framework.
Think of this decision guide as your cheat sheet. If safety is your number one priority, especially with tough materials, pre-drill a hole and a story. If you need insane precision for, say, an aerospace part, you're going to use helical interpolation. For general pocketing, ramping is super efficient. For those complex 3D surfaces, arcing in is perfect. And that straight entry, yeah, you save that for when you have absolutely no other choice.
All right, to wrap things up, let's go over some universal best practices. These are the pro tips that are going to help you get a perfect first cut, no matter which method you end up choosing.
Okay, let's recap these pro tips. 1. Strengthen your tool with a corner radius. 2. Always slow down your feed rate on those direct entries. 3. Give your chips a clear path out. 4. Pick strong tools for tough jobs. And maybe most importantly, treat every single cut like a conversation with the material. Be ready to listen to what the machine is telling you and adapt your strategy on the fly.
And that brings us to our final thought here at Next Gen Manufacturing. You see, the art of the first cut isn't static. As we push into new, advanced materials and demand ever-increasing precision, the strategies we use to make that first touch, they're going to have to evolve right alongside it. How we manage that first moment will always define the cutting edge of what's possible.